Welcome to today's math lesson. If you will go to Schoology and to your math course, you will find a pink folder labeled September 13th through the 17th. If you were absent on the 13th, there is a quiz there for you to take. If you wait too long, it might have already closed, but it is open until Monday, September 20th. So just if you were absent on the 13th, then you will take that quiz. It will take you to Edulastic to take that quiz. So again, just make sure that you complete that if you were absent on the 13th. September 14th through the 15th, we covered the same lesson. It's two sessions, session 1 and session 2. And when you go to September 14th through the 15th, right now all you see is this presentation here. Once I finish recording, you will also see a video that walks you through these steps and how to complete the assignment. So when you open that assignment, it will open the assignment and it will give you an option to open assignment with Kami. And we've done this in class a little bit, so we should be familiar with it. But you're going to open assignment with Kami. It will probably prompt you to log in with Google, and that is the option that you want to choose. When you open things with Kami, one of the reasons why I like using Kami is that it gives you all of these options on the toolbar over here on the side. You can draw on it, you can add a text box, you could put an equation in. There's all kinds of options here for you as a student to be able to write on these as if they were your math textbook sitting right in front of you. So, what these presentations do is they combine the slides that I'm going over in class with the textbook pages that we do in class as well. So, we had been talking about shapes and finding the area of shapes, two-dimensional shapes, finding the area of triangles and parallelograms, and even finding the area of polygons where you have a shape and then you are finding a way to break up that shape into multiple shapes and then finding the shape of each and then adding it all together. And then we moved on to finding the surface area of three-dimensional shapes. And we learned that three-dimensional shapes have nets, and you can always draw the net to help you find the surface area for a three-dimensional shape. Now we are moving on to expressions. And we talked about at the beginning of the year, we did a little bit of review with expressions, and we talked about how expressions are things like 3x plus 2 minus 4 plus 6. And the minus 4 might be in parentheses there. And so when you have something like this is an expression, and this expression has a variable. You might have worked with a few algebraic expressions or equations where you were actually solving for x in previous grade levels. We will start discussing how to create expressions like this to solve a problem. So you might have a phrase or you might have a word problem, and you would be responsible for creating an expression that matches the words in your problem. So you're not necessarily finding what a lot of my students like to call your answer. You're not finding a solution. You're not simplifying the expression. You're just identifying an expression that would help you find a solution to a problem. So when we're talking about expressions, we want to be able to write expressions, we want to be able to identify parts of expressions, and then we want to be able to evaluate expressions when we are given a value for their variables. So in this session, in these two sessions, We will mostly cover writing expressions that record operations and then also identifying parts of an expression. There are a few start problems with this lesson, so you can hit pause if you would like to and go ahead and do the start problems. So there's this one, and then there's your next one, and then go ahead and do the vocabulary for sum, difference, product, factor, and quotient. So take a moment to pause the video and respond to those, and then when you're ready, click play and we will go through correct answers. So for this first start problem, um, it says which one doesn't belong. And that's exactly what you're going to do. You're going to decide which one does not belong. Now, you could have actually found the solution or simplified or evaluate. That all means the same thing when we're talking about expressions. You could have actually evaluated each one to get your solution. You would discover that A and C um, have the same solution, B and D do not. So, as far as finding out which one doesn't belong, finding the solution doesn't really help us as much with this one. However, if you made a statement that is true and justified, then your answer should be correct. For example, I might say that A does not belong because it includes brackets where the other expressions do not have brackets. That is a true statement. A has brackets, the others do not. So, as long as your statement is true, then you have the one that doesn't belong. Some might say that B doesn't belong because it has division and none of the others do. So, again, as long as your response is true, then you should have a correct answer there. For same and different, your next start problem. With this one, if you were to actually solve every one of these expressions, they all have the same answer, the same solution. So 2 plus 2 would be 4, plus 2 more is 6, plus 2 more is 8. Here, if we're following our order of operations, we multiply first 4, add that together, and we get 8. 4 times 2 is 8, and then 4 plus 4 is 8. So that's something that they all have that's the same. They all have the same solution. They are all expressions. Um, some things that are different. C is the only expression that uses only the number 4. A and C use repeated addition. B and D use multiplication. Um, B also uses addition there as well. So anything that you come up with that's the same or different about those expressions is a correct answer. So we're moving on to the vocabulary. Most of this should be a review for you, but when we're talking about the vocabulary here, sum, if we're talking about the sum, then we are talking about the answer to an addition problem. So when we're talking about the sum, we're talking about the answer to an addition problem. We could even say that we are talking about um, what you get. Let's see. Let's go. Uh, what you get when you add two or more. We'll use numbers. Um, or let's say terms. We will learn what terms are later in this session. So, the answer to an addition problem, or what you get when you add two or more numbers or terms. An example of this would be 6 plus 7 equals 13. 13 is the sum. All right, let's take a look at difference. So as far as difference is the answer to a subtraction problem. Or again, we could do something similar with our definition here and say that this is what you get when you subtract two or more numbers. What you get when you subtract. So for this, we could say 12 minus 6 equals 12 minus 6 equals 6. So the difference is going to be 6. Then we have the word product. So a product is the answer to a multiplication problem. You could have something like 3 times 3 equals 9. 9 would be our product. Then we have the word factor. Factor is, we could say that is the numbers or terms that, well, not use terms there. The numbers or variables that you multiply. For example, you might have in that 3 times 3 equals 9. Your factors would be 3 and 3. Then we have the word quotient. This is the answer or solution to a division problem. An example here might be 3
Words example.
Hold on, it's giving me a little bit of a fit here. Here we go. Okay. Might be 33 divided by 3. That would equal 11. So our quotient would be 11. All right. So those are definitions of terms that we should be familiar with from previous grade levels. I hope that those were easy ones for you to remember. Let me erase my screen. And we will take a look at our next set of terms or vocabulary for this particular lesson. Okay, our next set of vocabulary are words that we will use to identify the parts of an expression. So when we talk about expressions, we sometimes will need to identify the terms in an expression. So when we're talking about the terms, those are the things that you add or subtract. Um, Something to note here is that it is separated by addition or subtraction. So that is what a term is. An example of this would be if I had something like 3x plus y minus 4 times 2. So anything that is separated with addition or subtraction is a term. So 3x and y are separated by this addition symbol. So those are terms. 3x and y, those are terms. And then y and 4 times 2 is separated by a subtraction symbol. So that is another term in this expression. So that particular expression has 3 terms. Then we have constant. So when we're talking about constants, those are the terms that don't get multiplied by a variable. So if we stick with that same expression there, and we have 3x plus y minus 4 times 2, then the only part of that does not contain a variable would be this term right here. So that 4 times 2. Then we have something called coefficients. And coefficients are the factors that are multiplied by the variable. For example, if we're looking again at that same expression, 3x plus y minus 4 times 2, then we would say that 3 is a coefficient. Some might say that technically this is 1y, so there would be a coefficient of 1 there. But we are not going there just yet with our expression. So anytime you see a number next to a variable, that is going to be a coefficient. Next, we have variables, and variables are the factors that can change. They are usually represented by a letter, such as N is very popular, X, Y. Um, so if we are sticking with that same expression that we looked at before, we have 3x plus y minus 4 times 2. And if we're identifying the variables, those are our letters. So we have x and we have y. Those are the variables for that particular expression. So we do want to be able to identify all of those parts of an expression. In fact, some of our questions will ask us to simply just identify parts of an expression. So we want to make sure that we're able to do that. So let's take a look at our next set of problems. This brings us to our first problem. And I apologize for the green circle. For some reason, that will not erase off of my screen. So we have Kaylee. Kaylee is making a long bench for a daycare center. She connects 1-foot wooden cubes in a row. She will use fabric to cover the bench on all sides, including the bottom. What is the surface area to be covered with fabric if Kaylee uses 20 cubes? So if you were in your math textbook, this would be on page 65. The part that is not included in your math textbook is this blue table of information here. So when we're looking at this, what we want to do is we want to say, okay, if we have 1 cube and I wanted to cover 1 cube with fabric, and on this cube I have, just as the problem says, I have 1 foot by 1 foot. Well, that surface is a square. And to find the area of a square, we would do length times width. So 1 times 1 would be 1. Now, if I want the surface area of the entire cube here, that cube has 6 surfaces. Each of those surfaces has an area of 1. So if I have 6 ones, then I have 6. So my total surface area for 1 cube is 6. So if I have 1 cube, my surface area is 6. If I have 2 cubes, we might naturally think, okay, well, if I have 6 for 1 cube, then I double it if I have 2, and then I have 12. But we have to pay attention to a pattern here that is occurring. So when we put the cubes next to each other, we don't count these sides here in the middle because they are now connected together. They are no longer sides. So every time we add a cube, we do double the front and the back, and we do double the top and the bottom. However, we do not double the sides. The sides, there will always just be 2 sides. So if we had 1 cube, the front of our cube is 1. If we have 2 cubes, it's 2. If we have 3 cubes, we're just adding 1 more, right? So that would be 3. So every time we add a cube, our front, back, top, and bottom just adds to that. Our sides, our left and our right, will always be 2. So if we're looking at this, then we can say, okay, One cube has a surface area of 6. If we're looking at two cubes, and I'm looking at this, then I can say this surface area was 1, this was 1, right? Together, that is 2. Same thing for the top. It has a surface area of 2. And then the back and the bottom also have a surface area of 2. So the front, back, top, and bottom each have a surface area of 2. So if we wanted just the surface area of the front, back, top, and bottom, then we would add all of these together. So 2, 4, 6, 8. We would have 8. Now we have to consider that we also have sides. We have a right side and a left side to this row of cubes. And the surface area of each side is 1, and we have 2 sides, so we add 2. So we have 8 plus 2. That will give us 10. Let me see if I can make that a little neater, guys. So if we have 8, we add 2, then we get 10. Then I can look at 3 cubes. If I have 3 cubes, then my front piece is 3, which means the back is 3. So the front is 3, the back is 3, the top and the bottom are each 3. So that's 3 plus 3 plus 3 plus 3. Now wait a minute. When I did 2 cubes, and I did the front, the back, the top, and the bottom, that was 2, 2, 2, 2, right? When I had 1 cube, the front, the back, the top, and the bottom, they were each 1. I see a pattern here. 1 times 4 will give me the surface area of my front, back, top, and bottom if I have 1 cube. 2 times 4, front, back, top, bottom, that's 4 different sides, right? So 2 times 4 would give me 8, which is my total surface area for 2 cubes. The same is true for 3 cubes. If I have 3 cubes and I multiply that times 4, 3 times 4 is 12. So each time I have my cubes, I can take my number of cubes, whatever that may be, multiply it times 4, and that gives me my area of the front, back, top, and bottom. It works that way every time. 3 times 4 is 12. And we said we have our 2 sides, so we would add 2 to 12, and that would give us 14. So we would have a total surface area of 14. And if we follow that pattern, we could find the surface area for any amount of cubes. So let's say that we had 12 cubes. If I had 12 cubes, and I multiply that times 4, 12 times 4 would be 48. Then I can add 2 for my left and right sides, and now I have 50. My total surface area would be 50. Now that I see this pattern that has evolved in this chart, I now can write an expression. And this expression will help me solve this problem no matter what amount of cubes I have. So it is your number of cubes, which is unknown, right? That's our variable. I'm going to use C to represent the number of cubes. The number of cubes times 4. Anytime you have two numbers or a number and a variable sitting next to each other like this, that tells us that we are multiplying them. So that is saying 4 times C. So 4C plus 2. And then I just plug in my number of cubes for C. In this particular problem, they're wanting to know for 20 cubes, what would that surface area be? So we're going to say 4 times 20 plus 2. Well, 4 times 20 is 80, plus 2 would give us 82. So we have 82 feet squared. That is how much fabric that will be needed to cover the surface area of Kaylee's bench. The next slide is just a discussion slide where if you were in class with us together, we would be discussing the patterns and everything. So it's what we just did on the previous slide, but it's a chance for you to repeat what we just talked about to a partner in your group. So if there's someone at home that you would like to share what we did with and explain to them how to solve this problem, so you would just be repeating what I told you earlier with this problem and how to find the answer. This also concludes the first session of this lesson. So if you want to pause the video for today and then pick it back up and continue tomorrow, you can. Or if you would like to move on through, we will continue talking about expressions, how to write them, and how to identify the parts. So we already discussed the terms here and what each of them mean as far as an equation. What I want you to do is, if you have your math spiral, you can pull that out and do this in there. If you don't, you can just do it on the screen. What we're going to do is we're going to go over some different equations with explaining these different parts. You can click on this box here. It takes you to a video for Khan Academy, and it does play on YouTube, so it should be good for you to play. This video will walk you through some different expressions and just how to identify those parts as far as terms, factors, coefficients, variables. So if you would like some extra help or insight into that, definitely watch this video if you get a chance. We are not going to watch it right now, but in your spiral or just on this page here, we're going to ignore where it says look back, what is the surface area, because we already talked about that. So what I want to cover with you guys, I want to actually discuss with you some different expressions. We're going to go over at least 2, and we're going to identify the parts to these expressions. So the first one that you should have in your spiral is going to be the example here over to the side. It's going to be 3x plus 5y minus 9. Now, when we're talking about expressions, we can identify terms. And we said earlier that terms are those things that you're adding or subtracting. So we have term 1 right here. I'm going to put T1 for term 1. Then we have term 2. And we have term 3. So this particular expression has 3 terms. Each term has factors. So for this particular expression, 3x, that's the first term. It has 2 factors. Its factors are 3 and x. Term 2 has 2 factors as well, 5 and y. Term 3 only has 1 factor, and that would be 9. So that is how you determine terms as well as factors in an expression. Then you can take a look and find your variables, constants, and coefficients. So we have 2 variables in this particular expression. We have x and we have y. So those are our variables. Those are our unknowns. We have 2 coefficients, 3 and 5. Those would be coefficients. Coefficients are the numbers that are multiplied by your variable. In other words, they're the numbers sitting next to your variables. So 3 and 5 are our coefficients for that expression. And then we have one constant, 9. 9 is a term that does not contain any variables, so that one is a constant. That term is constant. If I went a little fast for you, you're welcome to rewind, pause as you go along as needed. Just make sure that, again, you've either put this on this page or put it in your spiral. Now we're going to go over a different expression. So we're going to look at 2 times 4b plus 6xy. Okay, so looking at this expression, there are terms. There are 2 terms in this expression. This is term 1, and this is term 2. So in term 1, we have 3 factors. We have 2, 4, and b. Those are our factors. In term 2, we have 3 factors as well. We have 6, we have x, and we have y. So those would be your terms and your factors for this expression. Then we have some coefficients. We have 4, that's next to that b, right? And we have 6. And some might even say that 2 times 4 is the coefficient here. And that would be okay as well. This particular expression does not have any constants. So we have identified our parts except for our variables. So b, x, and y. Those would be our variables for this expression. So again, make sure that you have recorded these either on this page or in your math spiral. And if you need to go back and look at them, you can. Or if you're just not feeling comfortable, remember to click over here on this video and you can watch some more examples. We are going to skip over this connected section and that discuss it where you're reflecting right there. And we're going to move on. We do need to remember what our goals are. So we want to be able to write expressions, We want to be able to identify the parts of an expression, and then we want to be able to evaluate expressions when we are given specific values. And the ones, again, that are in this session are going to be um, so the two that we want to focus on are right expressions and identifying the parts in these two sessions for these 2 days. So we want to be able to write the expressions and identify the parts. We will get to evaluating expressions in our next session. This brings us to our next problem. So what I want you to do is I want you to take a minute, I want you to pause the video, and I want you to read this problem, identify important parts, and then hit play, and we'll go over how to create an expression for this. So for this particular problem, we have the Ramirez family, and they are making tamales. They wrap the tamales in corn husks for baking. They already have 8 corn husks. Isabel is bringing 3 bags of corn husks. Each bag has the same number of corn husks. So we know that there's something that's not going to change here. We know that they are going to have 8 corn husks. They have 8 and someone is bringing more. So if you have some and someone gives you some more, then we say that we are adding. So they have 8 and they're adding some more. The next part says 3 bags, each bag has the same number. So let's think about if I were handing out bags of candy and I gave each student 3 bags of candy. And inside each bag, there were 3 pieces of candy. So, well, let's do a different number than 3. Let's do 4. 4 pieces of candy. So 3 bags, 4 pieces of candy in each bag. How would we figure out how much candy each student is getting? Well, we would want to multiply. We have 3 bags times 4 pieces in each bag. So that's a total of 12 pieces for each student. To get that, we took the number of bags and we multiplied it by the number of pieces that were in the bag, right? So we want to do the same thing here. We know that we have 3 bags. We're just not quite sure about the number of corn husks inside of each bag. So this is our algebraic expression that will give us the number of tamales that they will have after Isabel arrives. Again, they're not asking you for how many corn husks they're going to have. They're just asking you how can you use an algebraic expression to show the number of corn husks that they will have. So this is an algebraic expression, so that is our final answer. We are going to skip over the model it for now. We will do some model it with some algebra tiles in class. So that brings us to the apply it problems. So we have Gasper. Gasper writes the algebraic expression 5b plus 3 and 79 hundredths. It represents the total cost in dollars of buying 5 bagels and a container of cream cheese. Identify any variables, coefficients, and terms in the expression, and then tell what each represents. So, we are not finding the total that it cost. What this problem wants us to do is it wants us to identify these parts of the expression and then tell what each of those parts represent. So first, I would write my expression. Sorry. It is not 3. It is 5b plus 3 and 79 hundredths. So we have two terms here. We have 5b, that's term 1, and then we have 3 and 79 hundredths. That would be term 2. Term 1 has two factors. It has 5. 5 is a coefficient, and it also tells us that it tells us the amount of bagels that are being purchased, because it says buying 5 bagels. Then in term 1, we see B. B is a variable. B represents the cost of each bagel. We don't know how much it cost. So maybe Gasper hasn't decided what kind of bagels, or maybe he just hasn't decided which store he's going to purchase his bagels. So B is the cost of each bagel. Then we have term 2, which only has one factor. It has no variables, so it is a constant. So 3 and 79 hundredths. So we know the amount of bagels. We don't know the cost of each, but we do know that he is purchasing a container of cream cheese. So that is what this represents. It represents the price of the cream cheese. So we have identified each and every part of that expression. That brings us to question number 8. It says, write an algebraic expression for the word phrase below. Which factor of your expression is a sum of two terms? So we have a phrase. The phrase says the product of 5 and 8/10 and the sum of 9 and a number. So we need to look at this and say, okay, the product. We know that the product is the answer to multiplication. The product of 8 and 5/10 and the sum. So that's what we're multiplying together. 8 and 5/10 times the sum. Now, the sum. What is the sum? Well, the sum of 9 and a number. And it specifically tells us that we need to use n as our variable. So 9 plus, because we have the sum, 9 and n, because that's what we're using for number. So I can write that as an expression. 5 and 8/10 times 9 plus n. Now, that is an algebraic expression. That expression only has one term because we have the product of. That term has two factors. It has 5 and 8/10, and then it also has the factor of n, or not n, of 9 plus n. Both of those are factors. The question asks you, which factor is a sum of two terms. Well, sum is adding, so you're looking for the factor that shows that you are adding. So for this particular expression, 9 plus n is the factor that's showing a sum. That brings us to B. B has similar instructions. So you're going to write the expression, and then you're going to decide, is your expression a difference or a quotient? So difference, remember, that is the answer to a subtraction problem. Quotient is the answer to a division problem. And then they want you to explain. Okay, so let's take a look at this. It says subtract a number, x. So we're going to replace number with x, right? From 15. And then it says and then. So that tells me that whatever came before and then, that's what I'm doing first. So I subtract a number, which is x, from 15. So I have 15 and I subtract a number. I don't know what that number is. We're calling it x. So subtract a number from 15, 15 minus x. It says, and then divide by 2. Well, I want divide by 2 to come second. So if I want something to come first in my expression, I first have to put grouping symbols so that I know, oh, wait, that's what I need to do first. I need to do 15 minus the number and then divide by 2. So if I'm doing my subtraction first and my division last, if division is my last step, am I finding a difference or a quotient? And for this particular expression, I am finding a quotient. So that is what I am doing in this expression because division is my last step. This brings us to the last question for these two sessions. Laquetta has a $50 gift card from an online music store. Each song cost S dollars. Write an algebraic expression that represents the amount left on the card after Laquetta buys 7 songs. Show your work. So I'm going to give you a little bit of help on this one, not a whole lot, because I do want you to do some of this on your own. So Laquetta has a $50 gift card for an online music store. So she has $50. We know that, right? Each song cost S dollars. So song is being represented with S. And it says, write an algebraic expression that represents the amount left on the card after she buys 7 songs. So this is the price of the songs, right? That's S. And she buys 7 of them. So she had $50, and we're going to subtract the cost of 7 times the amount. So she's getting 7 songs for a certain amount. We don't know the amount yet. If I were going to a store, I might say that I am purchasing 4 handkerchiefs for $1 a piece. So I would say 4 times $1, which means I'm spending $4. We know that she's buying 7 songs. We just don't know how much the songs cost. So we're still multiplying. We just don't know what we're multiplying together. So you are going to answer that question to write an algebraic expression that represents the amount left on the card after Laquetta buys 7 songs. Once you have done that, you have completed this session, well, these 2 sessions. And remember, our goals here were to be able to write an expression that records an operation, and then to also identify parts of an expression using mathematical terms. If you are done with this assignment, please make sure that you submit it. You can click Turn In over here in the top corner, and it will turn it in to me for you. And I will get a nice little message on Schoology telling me that you have completed it and turned it in.